One of my goals in restoring this old equipment, whether it be electronic or mechanical like this Friden calculator, is to help try and preserve some of the history of the development of things such as computers, why they came about, what was the need for them. These days they're mostly used at home for playing games on, but when they were first devised they had specific purpose. Now this calculator is a good example of that, and as part of the demonstration that I want to give today, I thought I'd give a practical example of why a machine like this was originally designed. A very good question was asked yesterday in the comments of one of the videos about this, and that is, why are there so many decimal points? And surely one decimal point per row of characters would be enough. That really comes down to two things. One is modern calculators are used for all sorts of things, or general purpose calculations, fault finding, they do many other functions, but they tend to always show a single decimal point. But one of the things that's not always fully understood with calculations mathematics is that if you take a single number, you can split it vertically into columns where you can effectively treat each block of columns separately. And that's one of the things that this calculator does. It allows you to fulfill functions that would otherwise have taken much longer for the operators to complete. One of those things is, for example, double entry bookkeeping, where you really want to do two sets of calculations at the same time. Or something even simpler, if we take something like this. So, simple bill of materials. We have a column that indicates the item, we have a column that shows the quantity of each of those items, and then we have a unit cost for the items. And the values that we want are the line totals, the grand total for the cost, and the number of components. Now what you could do, of course, is just tot all these up individually, enter the values. But it would get quite complicated because you'd have to multiply this by this, enter that, this by this, etc. So you'd have to do quite a lot of calculations. Whereas a calculator like this will greatly simplify the task if the operator knows how to use it successfully. Now, when this machine is used, if we enter a value into the dials just by doing a simple addition, so we've now got 77 in the top dial, 1 in the bottom dial. We can clear this in a variety of ways. We can use the slides. Incidentally, for this demonstration I've had to fit the broken button that I haven't yet replaced. So you can clear the dials by using the slides, or if you press carriage clear, it clears the dials. In some instances you don't want that to happen. So for example, if you are multiplying a series of numbers, the multiply function by default will clear the digits before it does the multiplication. But by setting the carriage locks, you can prevent it from doing that. So it will then just create a cumulative multiplication, and it will add the subsequent results to the previous results. But this machine's even cleverer than that. You'll see there's a marker halfway down the top row of digits. What that's for is to allow you to effectively turn this into a dual multiplication machine. That is, you can do two completely different sets of multiplications at the same time. And the way you go about that is to effectively decide which column is going to fulfill which purpose. So back to our example, I'll set up the machine to allow us to do this. Part of this is to effectively control the decimal place positions for each block of numbers and for the keyboards, both the main keyboard and the multiply keyboard. And where you put the decimal points is kind of up to you based on the maximum numbers that you need to represent. So in this case we're only going to need one decimal place before the decimal, so we can set up the machine accordingly. So the first thing we're going to do is we will have the bottom row of digits as the component count, so that will effectively be this value. We will have the line total, which is this one, effectively represented in the top right hand block of digits, and then the grand total for the cost will be in this block of digits. So if we want a grand total, that is a cumulative value, we need to lock the respective block of digits. And we have two locks for the top digits. We have this one, that will lock the entire block unless we use this one. Now this one will lock only this block. So in other words, if we leave this lock off and we put this lock on, then when the machine clears the top row of digits, it will only clear everything to the left of this marker. In other words, if we put something in here and then do a clear, notice it hasn't cleared this. If I put a value in here, so we've got a value in here and a value here, if I do a carriage clear, it's cleared this one, but it hasn't cleared this one. Okay. And one of the key features apparently of this machine is the ability to clear even locked values with the slide. So I'll clear that. So we'll lock that one. Also, if we're doing a cumulative total in here, which we're doing for the component count, we need to lock this value as well. So it's a bit difficult with this broken key, but let's see if I can get it to go on. There we go. So now this is locked as well. So the next thing to do is to set up the keyboard decimal place markers such that we can enter the values that we want to represent. So on the keyboard we'll only be entering the unit costs, not the quantities, but we will be doing it in two separate parts of the keyboard at the same time. So in the right hand part of the keyboard we will enter one set of values. In this case it will be for the total cost. So what we do is we put the decimal marker, that is we set the decimal marker in position 2, so that will give us 2 decimal points after the decimal. These don't do anything as far as the machine calculation is concerned, it's just so that we can correctly enter the numbers. And then we do the same thing on the left hand side. So in this case we only ever need to enter one value, one digit before the decimal, so we can put a decimal marker here. So we've now got 2 decimal markers on the keyboard, one down here and one here. So effectively we're going to split the keyboard in two and use the single keyboard to enter 2 sets of values at the same time. We now need to tell the multiplier where the decimal point should be. So that needs to be, again, 2 decimal places. So here we're going to enter the quantity of components. So it doesn't really matter how many decimal points there are after the value, simply because we're not going to enter fractions of a component. We don't deal with broken components, so there is no value in doing that. But we do need to keep the calculations fairly clear, so we'll use 2 decimal places for that as well. So I'll set the decimal marker to 2, and again this is for our reference only, this is just to make sure that we enter the numbers correctly. This now comes to the original point, which is why there is more than 1 decimal point per column. If we look at the likely outcome of doing these calculations, if we're multiplying values that have 2 decimal places, then we are going to need 4 decimal places, but we're going to need that twice, so because we're using this half and this half separately. So in the right hand column where our grand total is going to be, so our column total is going to be, we need to put this into position 4 because we need 4 decimal places. That's 2 times the individual column. And then in the left hand, because this is going to give our grand total, which will only ever have 2 decimal places, we put another decimal point, but this time we put it in position 2, or what amounts to position 2. So you can now assume this point with the marker is the end of the calculation point. In other words, anything after this will not be involved in the calculation for this side. So in other words, this is now 2 decimal places after the decimal point, and on this side it's 4 decimal places. And again, this will be effectively a completely separate number. In the bottom row, we need to put the decimal marker in the single column. If you remember, we're entering the numbers with 2 decimal places. So in this case, we will put the marker in position 2, so that then matches what we've got on the multiplier. So the machine is now set up to do these calculations. So you now see the power of the machine and why there are multiple decimal markers. This is a very simple example, but it gives you an idea as to why there are the various markers and carriage locks and whatever else, and why there are so many column decimal point indicators. So what we now do is we enter the values. We enter the cost in the keyboard and the quantity in the multiplier. But in the keyboard we enter it in both locations. We enter it on the left hand side and the right hand side. So the first one is £3.45. So we enter 345 in both sides, 345, and then the quantity is 45. So we enter 45, remember there's 2 decimal places. We then press multiply. What we now have is the grand total of 155.25, the row total 155.25, they're the same because this is the first row. And at this point you would enter that into your book, and then we have the total quantity, which obviously is 45. And the keyboard is cleared because we have the add key down. That causes the keyboard to clear at the end of each function. We now into the second one. The cost is £1.10. Very expensive resistors back then. So 1, 1, and you leave the key up for a 0. Same here, 1, 1, and then we want 28 of those. So 2, 8, and again 2 zeros to put the decimal point in the right place. Press multiply. And because the lock is on for this side of the carriage, it didn't clear this value before it did the calculation. So this is now a running total of both of these lines. Whereas on this side, because the lock is off, it cleared this half of the keyboard before it did the calculation. So this value is now just the line value. And obviously down here we have the running total of 28 plus 45. We do that for the remainder of the lines. So again, you would enter this value into your book. So the next one is £1.20. So enter £1.20, £1.20, and we want 15 of those. So 15, 2 decimal places. Total cost for that row, that component, is £18. And our running total has been updated, as has our running quantity. So that again, this value would be entered into your book. Next value, £6.89, 689, and the same on this side, 689, and we only want 2 of those. So 2 decimal places, multiply. I've been talking a lot through this, but even so you can see how quick it was to do quite a large number of calculations. What we've had as a result is other totals for the lines, which we've taken from here, and this last one is £13 something. This is now our grand total, so that's £217.83. That would go into here, and our total component count is 90. So that's an example of why you might need multiple decimal places. You can do much more complex problems than this, but it hopefully gives you an example of the power of a machine like this. Even doing this on a modern calculator will probably not really be much faster. And once you've got the machine set up and you understand how to use it, then you really can do some powerful calculations on this. I'm not saying you should carry one of these around in your pocket as an alternative to a modern digital calculator, but this was intended as an example as to why something like this came about in the first place, how it may have been used, and why it has the certain features that it does. If you're interested in seeing any more demonstrations or want to know what specific features do, then please drop a comment and I'll make a video to explain it.